Okay, my dear students, I am SK Sir, of physics teacher, and today I am presenting here the special video regarding the bridge course and how the bridge course can be completed within 1 hour, and is very important, very essential for those students who have already appeared the examination of SE and completing and taking the bridge course in different institutes. And so to meet the aims of the students who have already appeared the SE examinations and taking some of the classes in different institutes, I thought how they can meet the goal, how they can meet their goals regarding the bridge course. So I have presented, or I am going to present here, the completion of bridge course within 1 hour, and this is very important and essential. So यो च्यालेन्जिङ पनि हो। विद्यार्थी भाइ बहिनीहरू विभिन्न इन्स्टिट्युटमा कुदाकुद गर्दै ब्रिज कोर्सकै नाउँमा ब्रिज बनाउन गइरहेका हुन्छ, तर ब्रिज बनाउन सकिरहेका हुँदैन। ब्रिज भनेको के हो, ब्रिज चाहिँ कसरी गर्ने, कोर्सलाई ब्रिज कसरी गर्ने, त्यो अत्तो हुँदैन र न अत्तो नहुँदै चाहिँ 3 महिना पास भइसकेको हुन्छ। त्यसकारण यस्ता कठिनाइहरूलाई रिमुभ गर्नका लागि, यस्ता समस्याहरूसँग विद्यार्थी भाइ बहिनीहरू नझेलोस् र सकभर ब्रिज दिमागमा बनोस्, कोर्सको ब्रिज चाहिँ मोटामोटी रूपमा बनोस् भन्ने हिसाबले मैले स्पेशल ब्रिजको एउटा भिडियो लिएर आएको छु। मैले आफ्नो अथक प्रयास गरिरहेको छु सकभर भाइ बहिनीहरूको उद्देश्य र एम ब्रिज सम्बन्धी पुरा होस् र एसईसम्म पढेका जति पनि कुराहरू छन् ती सबै कुराहरूलाई, म्याक्सिमम कुराहरूलाई हामी ब्रिज बनाएर कसरी माथि लाने त है, त्यसलाई मैले म्याक्सिमम प्रयास गरेको छु र त्यही अनुसार विद्यार्थी भाइ बहिनीहरूले पनि यदि एफोर्ट देखायो भने पक्कै मलाई विश्वास लाग्दछ तपाईहरूले ब्रिज पढ्दै गर्दाखेरि जुन उद्देश्य बोकेर पढिराख्नु भएको हुन्छ त्यो उद्देश्य पक्कै केही हदसम्म, म्याक्सिमम हदसम्म पुरा हुनेछ र विभिन्न इन्ट्रान्स प्रिपरेसन गर्दाखेरि पनि कुनै स्कुलको लागि, कुनै कलेजको लागि तपाईहरूले इन्ट्रान्स प्रिपरेसन गर्दाखेरि इन्ट्रान्समा म पास हुन सक्छु कि सक्दैन, तीस जुन एउटा समस्या हो, कन्फ्युजन हो, भित्र जुन मिसकन्सेप्टहरू आइरहेका छन् त्यसलाई सम्भवतः हटाउनको लागि, रिमुभ गर्नको लागि मैले स्पेशल भिडियो क्लास लिइरहेको छु र तपाईलाई राम्रो पक्कै लाग्नेछ। राम्रो लागिसकेपछि तपाईहरू लाइक र सब्स्क्राइब पनि गर्न नबिर्सनु होला। मैले तपाईहरूलाई मात्रै ब्रिज कोर्स छैन, मैले तपाईहरूको मेडिकल इन्ट्रान्स प्रिपरेसन्सका क्लासेसदेखि लिएर इन्जिनियरिङ इन्ट्रान्स प्रिपरेसनका क्लासेसहरूदेखि लिएर +2 का 11 र 12 का स्पेशल क्लासेसहरूका निकै भिडियोहरू मैले तयार पारिसकेका छु। तपाईहरू जब 11 मा एडमिसन हुनुहुन्छ अनि भिडियो हेर्दै गर्दाखेरि तपाईँ पक्कै महसुस गर्नुहुनेछ कि वास्तवमा एसके सरले पढाउनु भएको भिडियो, सुर सरले पढाउनु भएको भिडियो हामीलाई कति फाइदामूलक छ वा छैन भन्ने कुरो तपाईँ पछि आफै डिसाइड गर्नुहुनेछ। भनेपछि आजको दिनमा मैले यो स्पेशल भिडियो क्लास ल्याउनुको मुख्य तात्पर्य नै हो कि तपाईहरू 11 क्लासको इन्ट्रान्स दिँदै जाँदा क्रममा तपाईले कुनै प्रकारको समस्या चाहिँ नआओस् र कुनै किसिमको कन्फ्युजन, मिसकन्सेप्ट सकभर नआओस् भन्ने उद्देश्यले नै मैले यो भिडियो स्पेशल तयार गरेको छु। साथसाथै तपाईँ 11 क्लासमा प्रवेश गर्दाखेरि जुन एउटा टर्मिनोलोजीहरू हुन्छन्, धेरै टर्मिनोलोजीहरू, जुन टर्मिनोलोजीहरू तपाईँहरू सुनिसकेका हुनुहुन्छ 9-10 क्लाससम्म, तर त्यसको वास्तविक मिनिङ चाहिँ बुझिराख्नु भएको हुँदैन, त्यसलाई लिङ्क गर्न सकिराख्नु भएको हुँदैन, लिङ्क गर्नमा कठिनाइहरू भइरहेको हुन्छ। त्यसकारण +A ग्रेड जिपिए ल्याए पनि त्यस्ता विद्यार्थीहरूलाई कठिनाइ भोगिराख्नु परिरहेको हुन्छ। त्यसलाई मैले सम्भवतः रिमुभ गर्ने प्रयास गरेको छु र विश्वास छ तपाईहरू पक्कै यो क्लासलाई इन्ट्रेस्टिङली लिनुहुनेछ भन्ने मैले आशा गर्दछु। ल, let's go ahead. Now we are going to start about physics regarding the bridge course of physics and how we people can complete the bridge course within 1 hour regarding the physics. So first of all, you should know uh, this physics is related to the science. So how you people can really link your concepts, what the ideas you people have already obtained in the lower classes, and how you people can link your ideas for the upper classes to level up your concepts and remove your misconceptions. So first of all, I would like to talk about the term science, because you people are learning the term science from the very beginning, and how you can just link your concept to the upper level by knowing the knowledge and understanding of the word science. Means science is really the refinement of everyday thinking, right, while doing the observations. So an experimenter or observer can make the refinement in everyday thinking during his or her observations is known as what? Science. Okay, this word is actually science. Now we are talking the physics part in science, so I would like to talk about the term what is physics. So to understand about the term physics, the complications of physics, first you have to throw your mind to the nature, because it is completely associated to the nature. So when you throw your mind to the nature, then it is related to the nature, and nature is not empty, not free, but is full of many more events, bundle of events. That's why nature is associated with events, and the events happening in the nature day by day, time to time, moment by moment, really not happening haphazardly or randomly, but they are happening in the nature on the basis of certain laws and principles. And so the events are related to the laws and principles as well. So the events are associated to the laws and principle, and it completely defines the term physics. That's why how we can say, how we can make our concept in our mind, the word physics means the study of nature and its laws is known as the physics, right? This is known as physics. So I have just talked here the events. Events means some of the events are happening day by day, time to time, moment by moment. For example, you people know the earth revolves around the sun. This is a kind of event on the basis of certain laws and principle. Similarly, the moon revolves around the earth on the basis of certain laws and principle. That's why it is also a kind of event. In the full moon night in the sea, tides are produced. This is also a kind of events. So there are many more events that are measurable or not measurable. Means observable or not observable doesn't matter, but you have to understand these are the events, and nature is full of completely events. So the study of nature and its laws is known as what? Events, is known as physics. Now as we talk the term physics, we have to talk about the observations. When we throw our mind to the nature, first of all we start our thinking from the observations. First we observe with the inner core of our heart and mind, in the presence of mind. And as we take the observations, in this scientific research, in scientific studies, we will face with the three types of variables. Independent, dependent variables are also over there. So we have to face different types of variables. So we should be very associated. We move towards the scientific study. As we talk the scientific study, regarding the scientific study, we have to face with different types of variables, right? That is dependent variables, independent variables. We have to face dependent. This is dependent variable. Similarly, next one is, this is independent variable, right? And another one is also, this is constant variables. This is constant variables. This is also constant types of variable is also there. This is known as the controlled variables as well. This is also known as controlled variable. Controlled variable cannot be changed while taking or explaining, or what we say, doing the different types of observations and doing manipulations and studying about the nature related to the events. So the control variable cannot be changed. So during the study, scientific study, control variables remains the constant. So that's why the next one, third one, is known as controlled variable. Controlled variables, and these variables can be understood by plotting a graph. While taking the graph, while taking the observation, after taking the observations about dependent and independent variables, the dependent variables is always taken dependent. Dependent variable is always taken along y-axis. This is dependent, and independent variable is always taken along x-axis. And as we plot a graph, and if the nature of a graph we found like this, straight line in nature, if we plot a graph between dependent and independent variable, taking the dependent variable along y-axis and independent variable along x-axis, we get a straight line graph passing through the origin. So it meets actually y goes to mx relation. So what you can say it here, this is m is equal to y by x. So this is y is the dependent, and x is actually independent. This is independent variable, and this remains constant. So the ratio of dependent and independent variable will be obtained from this graph, straight line graph passing through the origin, is constant. So this is called controlled variables. Even we are taking some observations regarding the dependent and independent variables, but after plotting the graph we get a straight line, then this constant is obtained, which doesn't alter the what we say dependent and independent variables. So this is known as actually controlled variables. This constant which doesn't alter, that's why it is known as controlled variable. This is called controlled variable. Okay, in this way, in our scientific studies, we are very concerning to this dependent and independent variable as well as controlled variables, because it plays the main important role in scientific studies, not only in physics but also it is associated to chemistry, biology, or whatever were there, earth science or the astronomy as well. Okay, now we move towards the actually physical quantity as well. So in physical quantity we move towards the physical quantity. Now regarding this physical quantity is in existence only if it has two parts. One is called numeric part. This is numeric part having only numerical value or numerical magnitude. Another part is also over here, that is also known as standard part. And this standard part is also known as unit. So the numerical value of a physical quantity is known as actually numerical magnitude, and this is an established standard reference part. And why physical quantity is named so? Because a number or a set of numbers, physical quantity means a number or a set of numbers which is used to explain the physical phenomena of nature associated with the events. in a quantitative way only. That's why it is termed as physical quantity, and this is in existence only. Keep it in mind, this is in existence only. Physical quantity in physics is existence only if it consists of two parts. One is numeric part, another one is what? Standard part, and they are in for a given or any interested physical quantity. Numeric part in a given physical quantity is always inversely proportional to the standard part. This is the link which level of your concept from the SC level to the higher level as well, because you have already listened about this physical quantity but won't have the ideas how a given or interested physical quantities are related with the numeric part and the standard part or unit part as well. And so this is very important concept is there. Okay, so this is very important concept. This is about the physical quantity, numeric part and standard part. Now I would like to move, as numeric part and standard part are there, then in our scientific research the error analysis is very important as well. In our scientific research, error analysis, error is very important. Error actually means discrepancy between standard value and observed value, right? This is actually, this error means uncertainty. This is uncertainty. Uncertainty is also known as error, and this is actually what do we call it? This is this error or uncertainty is the discrepancy between actually this standard value and observed value. Keep in mind, this is called error, and error is very important while doing some sort of research or in our scientific research. Error analysis is very important, because the error you have made or the result you have brought after your observation, collecting the data, is either correct or incorrect. If it is, nothing is absolute in the universe, so the result you brought from your observational data is surely not 100% correct, but it has some sort of error, and that error means that is the discrepancy between the standard value and observed value, right? So this is known as error, and error we talk is here. There are different types of error, we have to face it here. There are different types of error. Some sort of error is, this is absolute error. We talk absolute error, means absolute type of discrepancy is there, absolute error. And this absolute error implies actually the difference between standard value and observed value, right? Means calculated value, right? Observed value means calculated value, and this is the researched value, means empirical value is the standard value, right? So this is actually the difference, and this is known as absolute error. But as we divide by the standard value, it gives the relative error as well. It gives us relative error, and this relative is actually a standard value minus observed value over standard value. It gives us the relative error. But as we talk how much percentage we have made some sort of wrong or some sort of error or uncertainty, then we call it, this is percentage error as well. This is also known as percentage error, and this percentage error is actually a standard value minus observed value over standard value times 100%. This is the percentage error as well. Okay, and you should be very clear regarding to this. Means the error also depends upon different types of factor, different types of still some types of error furthermore are there. That is some instrumental error, personal error, random errors that cannot be controlled, that is not under the control of human being, that is known as the random errors as well. So all types of error actually plays the main important role in our scientific studies, right? So this is very important concept regarding the scientific study. Okay, now we move towards the force and motion. Regarding the force and motion, right? Regarding the force and motion, you should be very clear. First, regarding this force and motion, how the force and motion can be analyzed it here. How the force and motion can be analyzed. This is very important regarding this. And regarding this force and motion, force and motion, why it is named as force and motion? This is, if you apply the force on the mass may come into motion and tend to come into motion, right? That's why they are related as force and motion. This is also known as force and motion. Means motion is concerning to the mass, some sort of the material body, and force is the external agency which causes or tends to cause to come into what? Motion. That's why it is called force and motion. As the mass comes into motion, right, under the action of some sort of force, so it should be very much clear. There are two types of masses are there, different types of masses are there, because you have already listened about the term mass, but what type of masses you are knowing, you are not 100% clear. Some sort of mass in the nature is said to be inertial mass, that is inertial mass, right? And this inertial mass is really the accelerated mass, not at rest, but is accelerating in the nature, right? So the inertial mass actually follows Newton's second law of motion, that is F goes to ma. This is called inertial mass, and inertial mass is really not at rest but is accelerating, right? But is accelerating with reference to some frame of reference that is accelerating. So it follows Newton's second law of motion. So m goes to F by a is known as inertial mass, right? Another one is non-inertial mass as well. The second one is called non-inertial mass. Non-inertial mass. And non-inertial mass is non-accelerating mass. And non-accelerating mass is really under the gravitational attraction of the earth, right? Where we are where we are talking about the inertial mass, means the mass is under the gravitational force of attraction. That's why the mass which is under the gravitational force of attraction is known as actually gravitational mass or non-inertial mass as well. Okay, so this actually follows Gmm over d square. So here m goes to Fg d square over Gm is actually the gravitational mass. So one gravitational mass is also known as non-inertial mass, or this is also known as inertial mass as well. Okay, now we move towards the next type of mass also there in the universe on the basis of force field. The next type of mass is also there. One mass is actually source mass. One mass is source mass in the nature. Another mass is test mass as well. Test mass of the nature. So source mass means actually it produces very high gravitational force field, and test mass is also producing the gravitational force field, but its force field is so small that it can be neglected in comparison to that of source mass, right? For example, the mass of the bodies on the earth's surface, all are the test mass, but the mass of the earth is the source mass, or that is also known as source mass, is also known as point mass. Why we call it point mass or source mass? Because they except the source mass or point mass, other masses also produces the gravitational force field, which can be neglected in comparison to that of the point mass or source mass, because the gravitational force field produced by the test mass cannot offset the force field of what? Source mass or point mass. That's why it is called test mass, means the force, the mass on which the forces can be tested, affected by the source mass, is known as test mass as well. Okay, this is the reason why it is so. So it is very important regarding the source mass and test mass as well. Now we move to the acceleration due to gravity now, because the mass is affected by the acceleration due to gravity. You know the gravity, acceleration due to gravity. This is acceleration due to gravity. You have listened here, that is small g, acceleration due to gravity. So acceleration due to means the rate of change of velocity of a body falling only under the effect of gravity. That is known as acceleration due to gravity. And this acceleration due to gravity is found by the investigations. This g is inversely proportional to the square of the radius of the earth. That's why the value of g is changing from place to place on the earth's surface and is inversely proportional to the square of the radius of the earth. Why it is so? Because the earth is not perfectly spherical in shape but is elliptical in shape. You are looking, the earth is not perfectly spherical in shape but is elliptical in shape. So it has two types of axes. One is major axis, another one is minor axis. The major axis is towards the equator. The major axis is towards the equator and minor axis is towards the pole. That's why there is the radius of the equator and this is the radius of the what? Pole. And it is very much clear the radius of equator is more. Here RE is greater than what? RE at equator is greater than RE at what? Pole. That's why RE is greater than RE at pole. This is the reason why we can say the value of g on the earth's surface is changing from place to place, because the radius at the equator is less than to that of the pole. That's why the value of g at the pole, is greater than to that at the what? Equator. The value of g at the pole is greater than to that of the what? Equator. And from the experiment it has been found that this is the value of g. We have already found it here. G at pole we have found. This is 9.83 meter per second square. Similarly, g at equator also found it there. This is 9.78 meter per second square. So the average value g average we have found. This is 9.8 meter per second square. So this is why the value of g is changing from place to place on the earth's surface, because its shape is not perfectly spherical but elliptical in shape. Not only this, but also the value of g varies due to altitude, due to height and due to latitude as well. And you should be very much clear the value of g prime, the value of, this is apparent g, and the true g due to the height, the value of g due to height or altitude, height h or altitude, this g prime is equal to g times 1 minus 2h by re. So it should be very much clear. Means this is the inverse square variation. The value of g, this is true g and this is apparent g. This is g prime is apparent and g is true. But the value of g prime above the earth's surface, varies following the inverse square law. So it follows inverse square law above the earth's surface. But as we go below the earth's surface, beneath the earth's surface, due to depth, it is very much clear, due to depth g prime is equal to g times 1 minus x over re, where this h is the height and x is the depth. Means with respect to the depth, as well as we increase the depth as we go beneath the earth, the value of g gradually decreases. But this change is not inverse change, but this change is linear. So you should keep it in mind, the value of g is changing linearly. This is linear variation or linearly beneath the earth. This is linear variation beneath the what? Earth. So this is very, very important concept that you people have to keep it in mind, how the value of g is varying. Okay, how the value of g is varying. Similarly, as we talk the equations of motion, right? Equations of motion you know very well. The equations of motion in a straight line you know very well. Since s goes to ut plus half d square, right? Similarly, this v goes to u plus at, and next one is b square goes to u square plus 2as. These equations are true only for uniformly accelerating body, not for non-uniformly accelerating body. These equations are true. These are true for only uniformly accelerating body. only true for uniformly accelerated or upward when then A becomes minus Z and H, S becomes what? S becomes here H. So this will be changed. This will be changed. H goes to for upward motion. This is ut minus half gt square. V goes to u minus gt and v square goes to u square minus 2gh as well. But as the body falls only under the effect of gravity, as the body falls under the effect of gravity, keep it in mind, when the body falls only under the effect of gravity, if it is falling down, as it is falling down, then acceleration will be positive only under the effect of gravity. In this case, h goes to ut plus half gt square, v goes to u plus gt, and the next one is v square goes to u square plus 2gh. Okay. Similarly, the next factor is, should be very careful. We move towards the next. The next is, you are looking, you have already listened the free fall condition as well. Free fall. You have listened the free fall. Regarding this free fall, the reaction must be zero. The reaction acting on the body must be zero. So this is the condition of free fall. If R is equal to 0, then the free fall or weightlessness, we get the weightlessness. This is the condition of weightlessness. And relation the falling body, if the acceleration of falling body, if should be very careful, if A is equal to the acceleration due to gravity, then the reaction will be this. No doubt is there. Then what you can say, then R goes to actually m times g minus A, and if this is that, then it becomes 0. So this is the condition of weightlessness as well. Okay. Now we move towards the next liquid hydrostatic pressure, or this is also known as liquid pressure. Hydrostatic pressure. Hydrostatic pressure, or this is also known as liquid pressure. Hydrostatic means liquid, and pressure, this is hydrostatic pressure means this is P, and this is actually normal force acting per unit area. That is also known as fluid pressure or liquid pressure. This is true for fluid pressure or liquid pressure is the same. So normal force per unit area is this. But as we manipulate it here, then the liquid pressure we found rho gh here, where rho is the density of liquid, h is the height as well. So this is in SI system measured in Newton per meter square, where rho is the density and h is the height of liquid from the reference level as well. Okay, height of the liquid from the reference level as well. So as we talk about the next, this is sometimes we move towards the Pascal's law as well. Here is what is Pascal's law. Pascal's law of partial pressure. Pascal's law of partial pressure means when we put a liquid or any fluid in a container, then liquid pressure transmits equally in all possible directions. Liquid pressure transmits equally in all possible directions. Means, what does this mean? Liquid pressure transmits equally in all possible directions means, if we write F1 by A, right? F1 by A1 equal to F2 by A2 equals to F3 by A3. They all remains what? Constant. So liquid pressure transmits equally in all possible directions. That is known as actually Pascal's law, right? So the next is thrust. What is thrust? Thrust means this is actually the upward force applied by the liquid is called thrust. That is called thrust. And as we talk about the thrust, then we can talk about Archimedes principles as well. Should be very careful. Archimedes principle. Archimedes. This is Archimedes principle. Archimedes principle means what? Actually, when a body is wholly or partially immersed in a liquid, it loses its weight, and the loss of weight of a body is equal to weight of the liquid displaced, right? So this Archimedes principle means loss of weight, right? Loss of weight actually equal to the what is the loss of weight? Means weight of a body in air and weight of the body in what? Liquid. When means this is weight of a body. We take the weight of body in air, weight of body in air minus weight of body in liquid. Then this gives you the loss of weight. And this loss of weight actually equal to the upthrust. So upthrust is also equal to the loss of weight of the body. So this is called upthrust. Upthrust force means the force applied by the liquid to the upward direction. That is known as upthrust force. And this upthrust is equal to the loss of weight of the body. And this is true only when a body is partially or wholly immersed in a liquid. The loss of weight of a body is equal to the upthrust, or that is also known as the weight of liquid displaced as well. This is also known as weight of liquid displaced. That is called weight of what? Liquid displaced. Okay, this is known as Archimedes principles, and we move towards the next, that is known as law of flotation as well. Law of flotation. We talk about law of flotation means when a body floats on a liquid only. The body floats on a liquid only if the weight of a body is equal to the weight of liquid displaced, right? The body floats on a liquid. The body floats on a liquid only when weight of a body is equals to weight of liquid displaced. So how much part, to what extent or to how much part of the body is inside the liquid, right? Equal to that volume the liquid is displaced there. So the weight of a body is suppose rho. Rho means density of the body, means B means volume of the body, and G is the acceleration due to gravity. So rho V means mass and G, so this is the weight of the body. And if this weight of the body is equal to the weight of liquid displaced, right, means density of the liquid displaced and volume of the liquid displaced BL, and this is acceleration due to gravity. So in this case the relation is true, right? And this relation, so how much portion of the body is in water, that can also be evaluated from this concept, and is very much important is here. So what you can write it here, this is rho over rho L must be equal to VL over V, right, where V is the volume of the body, VL is the volume of liquid displaced, rho is the density of the body, and rho L is the density of liquid displaced as well. Okay, now similarly we talk about the next as well. This is CG, right? One is CG, right? CG means center of gravity. The center of gravity means the position where the total weight of the body is what? Located there, right? And next one is actually center of buoyancy. Center of buoyancy means center of gravity of the displaced liquid. This is center of gravity of the displaced liquid is known as center of buoyancy, right? Similarly, another one is the meta center as well. Meta center means the upthrust force passing through the center of gravity of the displaced liquid intersect the axis of the body on which the center of gravity lies. That intersected point is also known as meta center, right? And on the basis of the meta center, if meta center is above the center of gravity, right? Meta center is above the center of gravity, then the body sinks into the liquid. If the meta center is below the center of gravity, then the body floats on the liquid. Not only that, but also on the basis of density as well. If the density of the body density of the body is greater than density of the liquid, the body sinks, right? The body sinks completely. If density of the body is equal to density of the liquid, then the body just below the liquid surface. If density of the body is greater than the density of the density of the body is less than the density of liquid, the body just floats over the liquid surface. So this is on the concept of the density of the body as well as density of the liquid. Now we move towards the next, that is another one. We move towards the next, that is known as actually heat. Now heat, what is heat? Heat really the energy in transition, right? The energy in transition because of change of temperature between the two regions, right? So the energy in transition is known as heat. Energy in transition, energy in transition or transit is called actually heat, right? And if the energy is not in transition, that is not called heat. Keep it in mind. So there must be some sort of energy which is in transition, and transition takes place only if there is difference in temperature between the two regions, right? And this is actually how much heat energy supplied to the body can be denoted by the equation, that is m, yes, and this is actually theta 2 minus theta 1, where m is the mass of the body, this is the mass of the body, and this is a specific heat capacity, and this is the change in temperature, right? So if there is rise, change means rise or fall, doesn't matter, both equalizes the change, right? Change means rise or fall, that both are the change, So specific heat capacity, it also depends upon the specific heat capacity, means amount of heat energy required to raise the temperature of 1 kg mass of the body by 1 degree Celsius temperature is known as a specific heat capacity. So this relation is known as heat equation. This is called heat equation. And this heat equation, looking so simple, but is very important. Very important. This is known as heat equation. And this heat equation is very important. And really heat is measured, this heat is measured, its unit is, heat is measured actually, Q is measured in calorie, right? But this is written as calories, like this as well. But there is some mechanical unit with the calorific value of heat as well. So 1 calorie always corresponds to 4.2 joule. So you should keep in mind, you can convert the mechanical energy into the calorific value as well, and this is very important. And similarly, as we move towards the term temperature, and this is actually the hotness and coldness of the body is measured on the basis of the vibratory molecules, means to what extent the molecules in a body is vibrating or in motion, right? On the basis of that, there is the temperature of the body, so it gives the hotness and coldness of the body. And there is some temperature scales, temperature scales are also there. There are different types of temperature scales. We know very well, that is degree Celsius temperature scales, degree Fahrenheit temperature scales, degree Fahrenheit means degree Reaumur temperature scales, and also Kelvin temperature scales, and they are related. They are related with each other. But as we take different types of thermometer in different temperature scales, then we can find the relation, and this relation is also very important. The upper fixed point, suppose the reading in the temperature scale, degree temperature scales is C, right? And the lower fixed point is 0, right? Similarly, the upper fixed point is 100 in degree Celsius and lower fixed point is 0. Means this ratio is the same in each and every thermometers, in each and every scales thermometers, either in degree Celsius scale or degree Fahrenheit scale or degree Reaumur scale or Kelvin scale temperature scales. This such type of ratio is always the same there in each and every scales. As we talk about this degree Fahrenheit scale, the reading in the degree Fahrenheit scale is suppose F, and the lower fixed point is 32, upper fixed point is similarly 212 minus lower fixed point is 32. Similarly, the reading in the Reaumur scale is R, lower fixed point is 0, upper fixed point is 80 and lower fixed point is 0. Similarly, in Kelvin temperature scale, the reading is K, the lower fixed point is 273 and the upper fixed point is similarly, that is 373 minus this is lower fixed point to 273. So these all ratios are same, and that is found experimentally, or these are the empirical studies regarding this ratio, and is very important. Means what we can conclude from here, in degree Celsius temperature scale, the upper fixed point and lower fixed point, the difference between upper fixed point and lower fixed point in degree Celsius scale and that of Kelvin temperature scale is the same. That's why what you can say, C over 100 goes to F minus 32 over 180 goes to R over 80 goes to K minus 273 over 100. So it is very much clear the temperature difference between upper fixed point and lower fixed points in degree Celsius scale and that of the Kelvin temperature scale is the same. This is the reason why we can say this is one division in the degree Celsius scale reads 1 degree Celsius and one division in the Kelvin temperature scale reads 1 Kelvin temperature. Okay, this is 1 Kelvin. So 1 degree Celsius is also equal to the 1 degree Celsius 1 Kelvin temperature, because the sensitivity or the least count in degree Celsius scale and that of Kelvin temperature scale is the what same. Now another fact is here, another fact is actually Kelvin temperature scale. Means you are looking the reading in the Kelvin temperature scale is K and the lower fixed point is 273 and this is suppose theta. This is suppose what? Theta. So what you can say it here, this is Kelvin temperature scale is expressed in, this is theta degree Celsius, then what you can say theta plus 273 always gives you, this is called absolute temperature. This is called absolute temperature. This is absolute temperature. It is very important. This is called absolute temperature. But at absolute zero temperature, you should be very much clear the value of K is 0. This is called absolute 0. But as we write K is equal to 0, that is called absolute 0, and the above equation now becomes K goes to theta plus 273, or what you can say theta goes to minus 273 degrees Celsius. So at this temperature the volume of the body is minimum, right? The volume of the body is minimum and volume as well as kinetic energy is minimum of the body at this temperature. Okay, volume and kinetic energy is said to be minimum at this temperature, and so this is also known as 0 point. The energy associated at absolute 0 temperature is known as 0 point energy. Okay, this is also known as 0 point energy, that is the energy associated with the 0 point energy is known as 0 point energy associated with the absolute 0 temperature is known as 0 point energy as well. And at 0 point energy there is the minimum kinetic energy as well as minimum volume of the body is there. Now we move toward the next, that is known as wave. Look at here, this is wave. Wave is normally denoted by a letter psi. This is just like this is psi, symbol of psi is this, and this wave is actually What is wave? Actually, this is the disturbance that can transfer energy and momentum from one place to another place. So wave is actually psi, and this is carries energy and momentum. It carries energy. It carries energy and momentum. Carries energy and momentum from one point to another point. Another point is actually the this is carries energy, that is called what? Wave. Okay, if it doesn't carries, that is called wave. If it carries energy, then this is known as wave. But if it doesn't carries, the disturbance doesn't carry energy, then it is called simply vibration. That is called vibration, simply vibration. But here, in regarding the wave, there are different types of wave are there. That is mechanical, non-mechanical. Okay, on the basis of the necessity of the medium, on the basis of the mode of vibration, on the basis of the necessity of the medium. That is actually some side of wave is mechanical. Mechanical waves are there. On the basis of the necessity of the medium, mechanical wave needs the medium to propagate from one place to the another place, on one region of the space to the another region of space. Another one is non-mechanical wave, means it doesn't need the medium, material medium. Okay, but to propagate the wave from one place to another place, it should be very much clear. It should be very much clear that it must have, the medium must have inertial properties, elastic properties, right? Elasticity and inertia there must be, and low damping is there. So for propagation of the wave through the medium, for propagation of the wave through the medium must have different properties. So the medium must have the properties for its propagation. The medium must have some sort of inertia. The medium must have what we say elasticity. The medium have elastic properties. Elastic properties means similarly the medium must have low damping or low resistive force as well. So in the presence of these three properties, the wave can propagate from one medium to the another medium as well. Okay, as it propagates from one medium to another medium, right? Then what you can say it here, there is the disturbance which is carrying some sort of energy from one part of the region to the another part of region there. But here there are, on the basis of actually the mode of vibration of the material molecules or medium molecules, there is okay, on the basis of the transformation of energy, the waves are of two types. One is called progressive wave and another one is called stationary wave. Means progressive wave always moves to the forward directions, and stationary waves doesn't move, but the confined region of space, the molecules are vibrating only, but don't carry the energy from one part of the region to the another part. That's why this is known as this is called stationary wave. Okay, in this way, on the different modes, on the basis of different modes, different concepts, the waves can be classified in different ways. But there are some sort of electromagnetic waves as well, and that electromagnetic waves doesn't need any medium for their propagation. Means electric field develop magnetic field, and by the help of electric and magnetic field the energy propagates from one part of the region to the another part. That's why they are called electromagnetic wave, and its speed is near to the speed of light according to James Clerk Maxwell scientist. And this is C, means electromagnetic wave having a speed that is to the light speed to the order of 3 into 10 power what 8 meter per second. Okay, now we move to there is the refraction of light. Regarding the refraction of light, first of all we should actually wave is formed. Wave forms different waves forms the rays as well. So we should know the physical meaning of ray as we denote and we draw a line over a head that is known as ray. But what is the physical meaning of ray? You should be very much clear regarding to this. Means the direction along which the energy transfers, and can be denoted by a corpuscle of the beam of light that is known as ray. Means the physical meaning of ray is it transfers the energy and momentum along a fixed direction, particular directions, that is called ray. Okay, so this is the physical meaning of the ray. Now in refraction of light we have to understand in diffraction of light there is the electromagnetic wave, and that propagates from one part of the region to the another part. Okay, but as it moves from one medium, rarer medium, to the denser medium, it bends towards the normal because of decrease of the velocity of light. And we have already studied and listened about the refraction of light. Suppose this is glass. Okay, suppose this is glass slab and this is the normal. When the light is incident from the air medium, and this is glass medium, and this is normal N1, then bends towards the normal, and as it emerges out from this glass through the point next, then it goes away from the what normal, that goes away from the normal. So this is called the angle of incidence, this is called angle of refraction, and this is called angle of what? Emergence. Okay, so what happens there? The bending of light as it moves from one medium to the another medium, as it passes from one medium to the another medium, is known as refraction of light. Okay, and there is Snell's law for the refraction of light, and that Snell's law tells us that the refractive index is, this is the refractive index, mu Ri is the refractive index. This is the ratio of the sine of the angle of incidence to the sine of the angle of what? Refraction. So this is called refractive index. Okay, and regarding this, this is also known as Snell's law. This is also known as Snell's law. Okay, this is Snell's law. And another thing is there is absolute refractive index as well. Absolute refractive index means actually as we talk about the absolute refractive index, then we can compare the velocity of light in any medium with the velocity of light in the free space. So if we write mu goes to c by v, where c is the speed of light, in free space, and another one is the speed of light in the medium, so it gives us the absolute refractive index. Okay, but another one is the relative refractive index as well. Relative refractive index means this is here you are looking, I is the angle of incidence in the air medium or ready medium, and R is the angle of refraction to the denser medium. So this is known as the denser medium means glass, where the density is more there, and where the density is less, that is known as rarer medium. So rarer medium and denser medium can be named on the basis of the magnitude of the density of the medium. That's why as we write sin r in the air medium, ready medium having the less density, and r is the angle of refraction in the glass having the more density comparatively, so it is also known as the refractive index of glass with respect to air as well. So what you can say it here, the refractive index of glass with respect to air, this is known as relative refractive index. Okay, so if we talk it here in between the two media, then we can define the relative refractive index as well. This is relative refractive index we can say. So refractive index of glass with respect to air we can define it here. This is actually refractive index of glass, ratio of the refractive index of glass to the refractive index of what? Air. Okay, this is called the relative refractive index. But as the light passes from glass to air, then we can say the refractive index of air with respect to glass, so it can be written mu a over what? Mu z. Okay, so what you can say it here, we can write clearly from this relation, from this refractive index relation, actually a mu z multiplied by this is g mu a. Okay, this is always equals to 1. Okay, this is always equals to 1 because a and a cancel out. Okay, so how we can say it here, it may be written as this is LHS. We can write this is a mu g multiplied by g mu a implies mu g over what? Mu a multiplied by, again this is mu a over what? Mu g. This cancel, this cancel. Thus this product gives you 1 unity. So this is the concept of relative refractive index. Okay, but another one is the principle of reversibility of light as well. Principle of reversibility of light. But the care should be here. If the light passes refractive index, this is the principle of reversibility of light implies what? If the light passes from air to the denser medium, like this, it bends towards the normal. Okay, but as for the same glass slab, we can also define like this. We can also define like, if the light ray passes from this medium, denser medium, and emerges out to what? Rarer medium, then what happens here? Okay, so this phenomenon is known as reversibility, principle of what? Reversibility of light. So like this is here, this is, if we write angle of incidence I, this is angle of refraction R, and if here angle of incidence and here angle of refraction, then the value will be the reciprocal. Refractive index becomes what? Reciprocal. So if we write a mu z, refractive index of glass, this is glass and this is air, this is also glass and this is also air. So refractive index of glass with respect to air, a mu g, this is equal to sin I over what? Sin r is this. Okay, sin I over what? Sin r we can write, but as we write like this g mu a, but as we write like this g mu a, refractive index of air with respect to glass, then it becomes the reciprocal value. Okay, this becomes the reciprocal value. How it is say, this is sin r by sin I. So what you can write it here, this is sin I over what? Sin r. So we can write the relation, this is 1 over, this is actually a mu g. So this is known as principle of reversibility of light as well. Okay, so it should be very clear regarding to this. This is also known as the principle of reversibility of what? Light. Principle of reversibility of what? Light is there. In this way, when the light ray passes from one medium to the another medium, it bends, and it also follows the principle of reversibility of what? Light. Now we talk about the critical, we move toward the next, that is critical angle. Means what is critical angle? Critical angle, concept of critical angle is also important. Okay, so if there are two media, one is denser, another one is what? Rare medium, like this, and this is the normal n, and if this is the angle of incidence I, in such a way that after refraction it passes by grazing the surface of the slab, by grazing the surface of the slab, making an angle of what? 90 degree. Then in this condition only, this angle of incidence in the denser medium is known as critical angle. Means critical angle is possible only if this is R, here I is C, here you are looking, here I is equal to C, right? C is the critical angle if only if R is equals to us 90 degree. So as we talk about refractive index, as we talk about here, the refractive index of this is air with respect to glass, refractive index of air with respect to glass, then what you can say it here, this is sine I, okay, sine I over sine R, right? And as this is sine I over sine R, then we may write this is sine I means sine C, and this is sine 90 degree, that's why it is written as sine C. So what you can say it here, as we write it like this, according to the principle of reversibility, we may write refractive index of glass with respect to air is actually, what you can write it here, this becomes actually sine C or 1 over sine C as well. What you can say, this is 1 over what? Sine C. We can write 1 over what? Sine C here. So what you can say it here, this is actually mu G, or simply generalizing this we may write this is mu G as well, but this is with respect to glass with respect to what? Air. So this is 1 over sine C is the critical angle as well. But in this condition we should be very much clear regarding to this. There is some convention which is always constant. Look at here, but you have to understand, if C is, if angle of incidence is greater than critical angle, that is greater than critical angle, in this case total internal reflection takes place is here, right? Total internal reflection takes place. So you should be very clear regarding to this. Okay, now the another one is also over here. The another one fact for this is very important, that is we are talking about the prism. Means what is prism? Prism means the refracting media made of what? Glass, that can disperse the light into different colors, right? So that is known as what? Prism. So in this case, like this, suppose this is equilateral prism, and this is known as angle of what? This is angle of prism A, okay? Angle of prism A is this, understood? And if we suppose this is the face P, QR, and if the light ray incident on this face and this is the normal, then the light after refraction passes parallel to the lower surface, and as we draw the another normal like this, then what happens there, this light ray again emerges out. So this is actually angle of incidence, this is angle of refraction, and this is also known as angle of what? Emergence. But as we talk about in the case of this deviation, as we talk about in the case of deviation, then what you can get it here, if we produce to the forward direction the original light ray, if we produce it to the original direction of the incident light ray and the emergent light ray produces back, then it will be seen the light ray originally get deviated by some sort of angle which is known as angle of deviation delta, right, in the case of prism as well. And this angle of deviation after mathematical manipulation, this angle of deviation after mathematical manipulation in the case of prism, we will get it here, that is delta goes to I plus E minus R1 plus R2, where R1 is the angle of refraction to the face PQ, and R2 is the another angle of refraction to the face PR, and this will be actually the angle of prism A. That's why what you can say it here, this is delta goes to I plus E minus A as well. So this is the deviation in the case of the prism, and the prism can deviate the light by some sort of angle delta which is equal to I plus C minus A, where A is the angle of prism, right, and that is equal to R1 plus R2. Okay, so in the case of minimum deviation, if this deviation is minimum, if delta goes to delta minimum, then we can get, it is possible only, what happens there, what happens if delta tends to delta minimum, then we can get I is equals to E and R1 is equal to R2 is equals to suppose RC. That will be the same in the both cases. So it should be very much clear regarding to this, how it is so, that is very much clear. That is, if delta becomes delta minimum, this becomes delta minimum, and this becomes actually I plus I goes to minus A. So this implies 2I goes to actually A plus delta minimum. This becomes A plus delta minimum, like this. So the angle of incidence on the first face PQ can be expressed in terms of angle of prism as well as minimum deviation, and this is actually equal to A plus delta minimum over 2, right? So this is the angle of incidence in terms of angle of prism A and the minimum deviation delta. Also, regarding the angle of refraction in this case, we can say R1, this is A is equal to, since A goes to R plus R, that's why 2R goes to A. This implies R goes to A over what? 2. Now, then the refractive index can be defined in the case of prism as well. In the case of prism, the refractive index can be defined, and this is the basic concept of the prism. You people have learned to some extent about the informations and listened the informations in SE level as well, in 10th class as well. So mu, refractive index, can be defined. Okay, refractive index mu is equal to, according to Snell's law, sine I over what? Sine R. So I is, you are looking here, sine A plus delta minimum over 2 divided by sine A by 2. So this is very important relation for this refractive index in the case of what? Prism. Now the next we want to move towards the dispersion. This is dispersion of light. Light get dispersed into 7 different colors, right? The phenomenon of splitting of light, into different colors, right? Into different colors. Suppose this is 1, 2, 3, 4, 5 different colors. They are splitted into different colors. 1, 2, 3, 4, 5, 6 and 7. They are split into different colors due to different wavelengths. They are split into different colors. Then this phenomenon is known as such phenomenon of splitting of a white light into different colors is known as actually dispersion of light. So there the more deviation is there for violet color, VIBGYOR, and the least deviation is for red color. Okay, so for red color the deviation is delta R. For violet color the deviation is what? Delta V. So deviation is more. Here deviation for violet color is greatest and that of the red color is the least. Understood? So on this basis, what you can say it here, on the basis of this deviation of light, on the basis of the deviation of different colors, what you can say, the different color having different frequencies as well as different energy. The more is energy, the more is the frequency. The more is the frequency, the more is the energy, and the more is the what? Deviation. The less is the frequency, the less is the energy, and the less is the what? Deviation. But frequency is more, then wavelength is what? Less there. So for deviation of violet color, for violet color of light, there is more energy, more frequency, and the least wavelength. That's why lambda is minimum. This implies lambda is minimum for violet color and lambda is maximum for red color. So on the basis of lambda of different colors, we can say there is deviation of what? Light. Okay, there is deviation of light, and this is the reason why in the case of lens there is chromatic aberration, means the coloring defect of images. For the single object there will be different images that we can see on the screen, and such aberration of the image due to different colors is known as chromatic aberration. Okay, so as we move towards the lens, means lens like this, there are two bulging out surfaces. The middle portion is bulging out, called convex lens, and the middle portion is thin but sides are thick. This is called concave lens. Concave lens is this. This is concave lens, and this is called convex lens. Okay, this is called convex lens. Here is thick, middle portion is thick, but in case of concave lens, the middle portion is what? Thin. But this is also known as converging lens. Convex lens is also known as converging lens, and this is known as what? Diverging lens, and its middle is known as, actually this is the pole, right? And this is also known as what? Pole is here. So this should be very clear regarding to this. Its focal length, in case of convex lens, focal length is F, positive. Radius of curvature is also positive. But in the case of this concave lens, should be very careful. The focal length for concave lens is negative and radius of curvature is also negative. This is the reason why for convex lens the power is 1 reciprocal of focal length. So the power for convex lens is positive, and the power for concave lens is what? Negative. Here is negative. This is the reason on the basis of the allocation of the focal length, whether it is positive or negative. Okay, and there is some angular magnification in the case of lens as well. Angular magnification. Angular magnification means what happens there. Suppose angular visual angle. One is visual angle. Suppose this is the eye. This is the eye. We suppose this is eye. This is eye, and this is an object. This is an object. So the angle made by an object at the eye is known as actually visual angle, alpha, right? So the angle made by, and similarly the angle made by the image at the eye is known as the another visual angle, means angle made by an object at the eye. Angle made by an object at the eye is denoted by alpha, and angle made by an object image at the eye is denoted by beta. So its angular magnification is denoted by, in the case of convex lens or concave lens, whatever be there, doesn't matter, this is always beta by alpha. So this is the angular magnification. Okay, this is the angular magnification. Understood? Now we talk about the next, that is the electricity and magnetism. As we talk about electricity and magnetism, write down. So as we talked about electricity and magnetism, actually we talk about the first we talk about the current, and this there are two types of current. Current means that is denoted by I, and this is the rate of flow of charge there. So this is measured in ampere. This is Q by T ampere, called rate of flow of charge through a point, is known as current. And this is two types of current is there. One is actually the current passes through the conductor, and one is called the direct current. This is direct current. Direct current. Another one is direct current. This is also known as DC. And another one is alternating current. Alternating current. Alternating current. That is also known as AC. But the distinction is that there is no change of magnitude and direction. No change of magnitude and direction. Suppose this is I and this is T. Similarly, this is current and this is what time, we suppose. But in the case of this DC, there is no change of magnitude and direction with respect to time. This is called DC, okay, and is actually parallel to the time axis and intersecting the current or voltage at the fixed value. But in the case of this alternating current, means altering magnitude and direction is altering with respect to a time. That's why it is like a sine wave. That is also known as sinusoidal wave, right? This is also known as sinusoidal wave, and we can write I naught sine omega t. This is actually a sine harmonic function. Okay, alternating current is in terms of the sine harmonic function, where I naught denotes its peak value. Okay, peak value or maximum value of current. That's why omega is actually 2 pi f. This is the omega is the angular frequency called 2 pi f, and f is the linear frequency. So from this information we can say there is the altering of magnitude and direction. Okay, in the case of alternating current, that's why it is named so. But if there is direct current, there is no altering of magnitude and directions. But as we move towards this, as we move towards the Ohm's law, then there are some conductors. This corresponds to y goes to mx, okay, and a straight line as well. This is a straight line. And so as we talk about the Ørsted discovery, Ørsted discovery, the Ørsted discovery is there, means magnetic field around the current carrying conductor. Magnetic field around the current carrying conductor is there, that is the Ørsted discovering in 1819. This is 1819 by Ørsted discovery. When current passes through the conductor, the magnetic field is produced around it, which is known as Ørsted discovery. But the magnetic field produced due to the current carrying conductor having magnitude as well as direction. So how we can find the direction of current and direction of magnetic field? There are three laws are there. Okay, in Ørsted discovery, to find the magnitude, direction of current and magnetic field, that is, first we call it right hand thumb rule. This is right hand thumb rule. Right hand thumb rule is there. Right hand thumb rule means like this. We can see it here. Right hand thumb rule. Suppose this is a conductor carrying current. Then as we catch it here and the direction of current is upward, direction of current is along the direction of the thumb, then the curling forefingers shows the direction of what? Magnetic field. So magnetic field is in an anti-clockwise direction if the current is flowing to the upward direction. This is very, very important concept. So on this right hand grip rule or thumb rule, we can find both the direction of magnetic field, current as well as magnetic field. But as we change the direction, reverse the direction of current to the downward direction, then we can just point the thumb of right hand like this, downward direction. Then the curling forefingers turn to the clockwise direction. This turns to the clockwise direction, so the magnetic field around this conductor becomes clockwise. In this case, that becomes anti-clockwise. So on the basis of right hand thumb rule or grip rule, we can find the direction of both current and magnetic field. Now the next one is cork screw rule as well. Next one is cork screw rule. Cork screw rule is also there. Regarding the cork screw rule, there is the screw. Okay, suppose this is a screw, and the direction along which the screw advances denotes the direction of current. Then the direction along which the screw is rotating. The direction along which the screw is rotating. The screw is rotating gives the direction of what? Magnetic field. That's why it is known as cork screw rule. Means according to the cork screw rule, the direction along which the screw advances during rotation denotes the direction of current. Then the direction of rotation gives the direction of what? Magnetic field. Similarly, the next one is right hand fist rule as well. This is right hand fist rule. Right hand fist rule as well. Means right hand fist rule means if the current is flowing through a circular loop or circular conductor, suppose this is the direction of current flowing through the circular loop like this. Okay, if we stand the fist of our right hand like this, and the curling forefingers denotes the direction of current flowing through the circular conductor, then the thumb points along a fixed direction where there will be the direction of magnetic field. That will be the direction of magnetic field. In this way, according to Ørsted discovery in 1819, the current carrying conductor produces magnetic field, and the direction of magnetic field as well as current can be deduced, can be found, can be confirmed by the three rules that is known as right hand grip rule or thumb rule, means cork screw rule, and right hand fist rule as well. Now exactly to the opposite rule, there is Michael Faraday. This is Michael Faraday. There is Michael Faraday discovered in 1831 the electric current due to or induced EMF or induced current due to the magnetic field. Means according to Michael Faraday in 1831, suppose this is a bar magnet and this is a coil or conductor. Suppose this is a coil or conductor, and this is the north pole and this is the south pole. If it moves towards the conductor, then what happens there, or to the coil or conductor, doesn't matter. What happens there, the current flows through it, through the coil, and such current is known as induced current. And this is observed, the current is observed in the circuit until the magnet is in what? Motion. Okay, so why it is so? Why it is so? Why it is so? It is due to the change of flux linkage in the conductor or what? Coil. Flux linkage means, what do you mean by flux? Flux means actually, okay, according to Michael Faraday in 1831, the electric current is induced due to the magnetic field or due to change of magnetic flux linkage in the coil or conductor. So suppose this is the bar magnet of N pole and this is south pole, and N pole is toward near the coil, carrying the near the coil, and when it is moved, when it is in motion, when the magnet is in motion towards the coil, then current is developed, and this current is developed due to actually the change of magnetic flux linkage in the coil, where flux is perpendicular component of magnetic field producing from the north pole and going toward crushing the conductor perpendicularly. So this is actually equal to B cos theta into A. So this is AB cos theta, and when theta is equal to 0 degree means the angle, the normal to the plane of the coil makes some sort of angle with the magnetic field is 0 degree, then at theta is equal to 0 degree we can write AB. So this is the magnetic flux, okay, and the magnetic flux linkage means if there are n number of turns in the coil, for n turns in the coil, for n turns in the coil, we can define flux linkage. This is the flux linkage, and this flux linkage is equal to n phi as well. This is the flux linkage. So because of this change of flux linkage in the coil, the EMF is induced in the coil, and according to Michael Faraday of electromagnetic induction, the induced EMF across the coil is directly proportional to the rate of change of flux linkage, means n d phi by dt. This is the rate of change of what? Flux linkage. So we can write this is actually equal to n d phi by dt. But the complication is here, if you write here, if this is the positive, then this is the induced EMF, and the corresponding current is known as induced current, and this is known as electromagnetic induction. Okay, so this is known as the principle of electromagnetic induction, means EMF is induced due to the rate of change of flux linkage in the coil, where n is the number of what turns with which the flux is linked. So the corresponding current is known as induced current, but this induced EMF produces the flux linkage, but the flux linkage actually opposes the cause which is producing it, that is known as Lenz's law, right? So if you write here negative sign, minus n d phi over dt, then this is known as Lenz's law. Means Lenz's law tells us that the induced EMF is opposed by the cause producing it. Okay, so EMF is produced by the rate of change of flux linkage. So the EMF produced opposes the cause producing it. The cause is rate of change of flux linkage, which is opposed by the induced EMF. That's why it is also known as back EMF. Okay, this is also known as back EMF. In this way, according to Oersted discovery, magnetic field is produced due to the current carrying conductor, but according to Michael Faraday discovery, the EMF is induced or current is induced due to the magnetic field. That's why there is exactly opposite effect. Okay, now the next one we talk it here, transformer. Transformer actually works on the principle of mutual inductance. Why mutual inductance is there? There is one is primary coil, another one is secondary coil, and in between two coils there is soft iron core. If current changes in the primary, then EMF is induced in the secondary. That's why phi in the secondary, flux in the secondary is directly proportional to the current in the what primary. So this is actually the principle of mutual inductance. On this principle it works. On this principle the transformer works, right? So phi s is equal to m times IP, where IP is the current in the primary coil and phi s is the flux in the what secondary coil. In this way, on this principle the transformer works. So transformer is said to be works on the principle of mutual inductance, and there are two types of transformer. One is primary step up transformer, one is step up transformer. Step up, this is step up transformer, one is step up transformer, okay, where the number of turns step up means number of turns in the primary is greater than number of turns in the what secondary. That's why it is number of turns in the secondary is greater than number of turns in the what primary. That's why it is known as a step up transformer. Why it is so? The low current, the low voltage at high current changes into high voltage at low current, so it is known as a step up transformer. Number two is a step down transformer. Step down transformer, because step down transformer number of turns in the secondary is less than that of what in the primary, means high voltage at low current changes into low voltage at what high current. That's why it is known as a step down transformer, where the number of turns in the secondary is less than that of what primary, means number of turns in the primary is greater than that of what secondary. But if the transformer is ideal, if the transformer is for ideal transformer, if the transformer is ideal, then P in is equal to P out, input power is equal to output power, and this is actually V input means Vp Ip. Vp means voltage across primary coil, Ip means current across primary coil, and V out means voltage across secondary and current across what secondary. So these products are the same. P in is equal to P out, means there is no loss of any sort of energy between the primary and secondary coil. That's why such type of transformer is known as ideal transformer, and ideal transformer is actually not in our practical life is available, because there is no 100% efficiency is available of any device concerned or constructed by the human beings. That's why there is some sort of errors as well, discrepancy as well. No 100% error will be there. Now I would like to move towards the universe. This is universe. Universe means universe actually on the basis of Big Bang. Big Bang of the universe by actually Big Bang theory, means Hubble's law is there. By Big Bang theory there is the existence of the universe is there, right? And there is Hubble's law as well. There is Hubble's law, means Hubble's law states that the matter in the universe is going away from us with more speed, means as the matter is going far, its speed gradually increases. So the speed of the matter of the star in the universe is directly proportional to the distance from the star to us. That's why this is known as Hubble's law, where V is equal to h times r, where h is the Hubble's constant, right? This is the Hubble's constant, and this Hubble's constant, this is h 2.3 into 10 to the power 17 second is there. This is known as actually Hubble's constant. This is 4.3, this is Hubble's constant is there. And according to this concept, actually the universe is day by day expanding, and universe is expanding here, and the light actually coming to the earth shifted to the red color as well. The light coming from the star to the earth shifted to the, sometimes shifts to red color, called that is called red shift of light. This is called red shift of light. Red shift of light is there, and red shift of light actually follows Doppler's effect. This follows Doppler's effect. Doppler's effect means what? There is apparent change in frequency due to the relative motion of the source and observer, that is known as Doppler's effect. That's why the red shift of light is obtained in the light that is coming to the earth from the star is on the basis of Doppler effect. Okay, so the future of the universe is there. There is future of the universe. Maybe there is closed universe, open universe, and flat universe. This is future of the universe. Future of the universe. Future of the universe means the future of the universe. Sometimes this is closed universe. This is closed universe, and another one is open universe, and another one is the flat universe. This is flat universe. And these three types of universe in the future can be explained on the basis of the density of the universe with its critical density. If the density of universe is greater than critical density, if the density of the universe is greater than its critical density, the universe becomes closed universe is there. But if the intensity of the universe, if the intensity of the density of the universe is less than the critical density, it forms the open universe. Similarly, if the density of the universe is equal to the critical density, then it forms the flat universe. In this way, we can conclude the future of the universe on the basis of density of the universe as well as with the critical density. Thank you very much. Yes. In this way, I hope all of you will really take some of the advantages and level up your concepts regarding the bridge course, and concisely I discussed the whole physics regarding the bridge course that will surely level your confusion within 1 hour, and hope all of will do the best in coming future in the field of physics. Thank you very much.